All right, so I gave the students 5 review problems. We're going to start the hour with that and see if you remember how to do this. So in this first one, you would start by subtracting 1 from both sides, and this 9 would become 8. And then you would put it to a power of, I'm going to flip the 3 over 2 into 2 over 3. Now, is this the kind that brings in an absolute value? No, it's not. But if you didn't even think about that, you could have got burned there. See, if this had been a 2 on the bottom, then you would have needed an absolute value on the x, or on the variable part. All right, but this one does not need that. That cancels that, and it's just x minus 3 equals, and you have a calculator for this test, so that shouldn't be too stressful. You could just type it in if you had to, but I'd like to think you could do the third root of 8, which is 2. 2 squared is 4. And then add 3 to both sides, x equals 7. Who had 7 for the first one? That's a good sign. All right, the next one. This really means x to the 2/3. The roots go on the bottom, just like in plants. Now notice, I didn't do anything to it. I'm just copying this in a different way. Now I'm going to do something to both sides. Now I'm going to put it to the 3 over 2. Is this the kind that needs an absolute value? Yes, it is. All right, so this cancels this, and I have absolute value of x, oops, there, equals, square root of 90, or 81 is 9. 9 to the 3rd, is that 729? All right, yes? All right, 729. So then my answer is plus and minus 729. All right, next one, this one. A whole lot of, these are unhappy, got to move them around. So then it ends up being, well, actually, I can just cancel them. There's the same thing on the top and the bottom. I could move them to be happy first and then cancel them, but they're going to get canceled. And these are unhappy, they go up to the top, and I have y squared equals 144. Square root on both sides is the same as the 1/2 power. Hopefully the person, could you open the door for that person, unless they look scary? Oh, they have a key, so they're going to be able to get in. Hi there. I'm going to pause the video for a second. Okay, back to this. So now, I just did the square root on both sides. Absolute value. And square root of 144 is 12. So it's plus and minus 12. Are you getting the feeling that you got to be careful with those absolute values? I hope so, because then you won't get burned on the test. All right, this next one. If you could just get them to both have a base of x, and you can. If you saw this, say this is x to the 3 minus m. See, because this minus this. And then 3 minus m must equal 7. So then I add or subtract 3 from both sides. Negative m is equal to 4. And then m equals negative 4. Who had negative 4 for that one? Okay, cool. And then this one. So squaring both sides, does that cause absolute values to come in? No. Now I get some people like, but they're square roots. You didn't personally square root both sides, so you don't have to bring in absolute values. 4x minus 2 equals x minus 4. Subtract x from both sides, we get 3x minus 2 equals negative 4. That's just a minus x. Now I'm going to add 2 to both sides. 3x equals plus 2, negative 2. X equals negative 2/3. Did anybody remember to check it? Nice. 3 kids, you can be proud of yourselves. Because if you check it, it doesn't actually work. And all you have to do is just stick it into one of them and you'll see, oh crap, I'm doing the square root of a negative. It doesn't even matter what the negative is. If I'm square rooting a negative, that doesn't work. Only 2 kids last hour caught it. Extraneous. This is one of the things that I'm going to say, this is a careful test. Math rewards careful people. So you're gonna have there's some kinds of times when it doesn't matter that much if you're careful. If a guy's like, I don't know, doing some yard work and it doesn't matter that much if he puts the boulder slightly in the wrong spot, okay? But if you're doing brain surgery, it matters. Well, math, it's like brain surgery. Make one little mistake, and I actually had a guy who was a friend who had brain surgery, and he came out way better, like a better human. Isn't that crazy? He used to be kind of grouchy and annoyed all the time, and he came out like happy and just like a cool dude from one little brain surgery. So I don't think that was the intention of the brain surgery. They were doing something else, but moral of the story, if you just do one little thing wrong in there, in this case, it ended up working out pretty good. But, all right, so enough about that. Who got 4 or better? 4 out of 5 or better. Nice work. Okay, now you know you. If you just got like 2 right out of 5, that sends up big warning flags that, oh crap, you are not on track. The test is coming. All right, now we should do a little bit of review of the this kind of thing. And I'm not going to do this one that's on the board because kids at home couldn't see it anyways. But we're going to make points like this. We're going to find points for a graph. Because I know you can all make dots. And I know you can draw a line through the dots. Okay, but can you find points for instance, this? 4 parentheses 2 to the x minus 3. Could you find me 3 points to graph for this puppy? Now, keep in mind, if your numbers get any bigger than 10, they're going to go off the graph. So choose wisely. Like if you just stick 5 in for x, it's going to be way too big. It won't work. Choose wisely what numbers to put in, because any number that gets above 10 will go off the graph and it won't count. You have to find 3 points where the numbers stay 10 or less. Now, I know some of you were taught a different way on this, and I think, I'm biased of course, I think the way I'm teaching this is way easier than what you did before. What you would have had to do before is memorize 3 points that always start your graph. And it would be okay. It's legal to do this. I also know from my tests that sometimes I've taught it this way in class, and then kids do it a completely different way that they learned off the key. Totally cool. You can do that. As long as you get it right, I don't care which way you use. But if you wanted to, you could memorize 3 key points that would be on the base function, okay? Or stick in 0, 1, and 2 and those, like make easy points. And then you'd have to add 3 to all of the x's and times by 4 to all of the y's. But that's like a really long process. And this way I'm showing you is just stick in any number you want, but try to make your numbers small. So how do I make this part small? 3 would be an awesome number to put in. How many of you already put in 3? Nice. You were thinking the right way. And don't be afraid of negatives. Like, if I put in a 2, it'll work really nice even though I get a power that's negative. Because if I put a 2 right here, 2 minus 3 will come out to -1, and 2 to the -1 is nice. It's a half. So I'm going to do that one right now. I'm going to put in a 2. 2 minus 3 gives me -1. 2 to the -1 power is just a half. And 4 times a half is 2. When I put in 3, here's a really common mistake. You put 3 in, and the kid thinks, oh, it's to the 0 power, so the whole answer is 1. No, not the whole answer. This part of the answer is 1. And then I times it by 4, makes it 3 comma 4. Okay, and the last point I would put in is just look at what you did. You put in 2, you put in 3. Duh, you probably want to put in 4 or maybe 1. Okay, I'm going to put in 4 and see if it gets too big. 4 minus 3 is to the power of 1. 2 to the power of 1 is 2. 2 times 4 is 8. That worked. Cool. 3 points. Raise your hand if you got 3 points. All right, awesome. Now, harder question. Where's the asymptote? Just pull up. You don't have to have graph paper. Just make a little sketch. Where would the asymptote be? I'll give you a hint. It starts as a horizontal line at 0. The question really is, did it move from there? Sliding it left or right won't move it. Multiplying it by something won't move it. What moves it? Moving it up or down. Did my transformations ever move it up or down? No. So then the asymptote is right there. It stayed there. And then I graph my points. Now, if I wanted to actually do this nice, I'll come over here to a nice clean section of graph. The asymptote would be right there. And then I would graph over 3, up 4, over 2, up 2, over 4, up 8. There we go. And that is not a straight line. It shouldn't be. And you should know asymptotic behavior, and that's where it's going to get closer and closer to the asymptote. There's my graph. Now, I want to have you try this, except on paper. So, those of you following along at home, we're just going to graph one on a piece of paper. You can use digital paper. I'm going to pause for a second while I hand out the paper. Okay, so for this one, make sure you include 3 points and the asymptote. And I feel like that is too hard. So we're going to erase the 1/2 in front. That's more reasonable. Just 2 to the x minus 1 plus 3. Okay, give it a shot. Graph this thing. Act like your grade depends on it. And then we'll grade them quick by handing it to another kid. And they'll give you an honest opinion on, give you a score of 1 out of 1 or 0 out of 1. Okay, so now you look at it there, graph. Now you might think you know, but let's just be sure. Here's what you're looking for. They could have graphed different points than you. I'll put a whole bunch up here. Jack, can you tell me 3 points that your person has?
Yeah. 1, 4.
1, 4, double checking it. It works, keep going.
2, 5.
2, and what's the next? It's gonna be 2, yep, 2, 5 works. Yep, what's the next one?
3, 7.
3, this one is 2. Yep, 3, 7 is also correct. I'm sure there's more. Would somebody please add a point to this? Just say it out loud. Yes? 0, double checking. 3.5 is correct. Anybody else have a point that they want to check and see if it's right? Yes?
-1, 3 1/4.
-1, yes. 3.25. Got any others that are represented in here? Okay, cool. Good. Then, where's the asymptote? Well, it should be shifted up 3. So, it should be up 1, 2, 3, dotted line across like this. I should probably use a brighter color. And then over 1 and up 4, over 2 and up 5, over 3 and up 7. There's my curve developing. I can now just complete. And do they have to have a line through the dots? Yes. Do they have to have an asymptote? Yes. Now, the asymptote does not need arrows on the end of it. It is implied. You can put them, but you don't have to. All right. Now, give them a score of either 1 out of 1 or 0 out of 1 and hand it back to them. All right, how many of you are feeling like you're getting the graphing? Raise your hand if you feel like you're getting the graphing. Okay, good. Then we just have one thing left to master, and that is today's new thing. It's an intense equation, but good news, we're going to give it to you on the test. But the problem is, we're not going to tell you what the variables in it means. Like for instance, this is one. Don't write this one down for now. I'm just telling you something. This is a famous math equation, and it only means something if you know that t is time. You could have maybe guessed that one. In fact, I'll have you guess. Since it's in the context of we do this one in this class, but this is not the one I need you to memorize. But what do you think R is? Just guess. Say it out loud. Rate is correct. Good. E is a number that's on your calculator. Does anybody know what it is? Yes?
10.
Nope. I know that there's a button on your calculator that says a capital double E. That does to a power of 10. So that's what you're thinking of. But just the simple E, okay, if you've got one of the graphing calculators, take it out because this could be on the test. If we had this formula given to you, you'd want to know where to find the E button. I have it memorized, but you probably would rather just know where it is on the calculator since calculators are allowed. And E is right above the divide key. If you've got one of those graphing calculators, look above the divide key, hit E, hit enter, and it'll tell you what it is. And unless I'm losing my mind, it's 2.718, blah, 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 blah. It keeps going on forever. It's kind of like pi. It's one of those numbers that goes on forever, never repeats. Okay? All right. So, in this formula, E is just a number that's kind of like pi. It's defined. It's always this number, 2.718. R is the rate, T is the time, and P is the, and we had this word before in one of our formulas. P is for, we have one at the school. Principal. Principal is correct. P stands for principal, and that's like the starting amount. All right, now, I'm talking to you to just show you. Do you get how, unless you knew what these letters were, it wouldn't help you that much if I just gave you the formula? Well, we're going to give you this formula that I'm about to write on the board, so write it down. But what's really important is that you memorize which letter means what. And it's V equals P to the 1 plus R over N to the NT. Whew, intense. Now, we're going to give you that formula. Then I just need to tell you what P and R and T and N and V stand for. And you already know 3 of them. Take a wild guess and write down what T stands for. Say it if you know it. Time is correct. Okay. Take a wild guess and say it out loud. What's R? Rate. And how about P? Principal. And that means starting amount. I would put start underneath it. V stands for value, and I'm going to squeeze the word end above it because whereas P is the start value, V is the end value. Then that leaves only one thing left, and this kind of rhymes with what we did in class in the loans and investments unit. Do you remember what the rate was always divided by when we were doing our monthly payments? 12. But I will tell you on a lot of your problems today, it's not monthly, it's once per year, which is annual. So do you get, if it was monthly, you'd put a 12 here and here. But if it's once a year, you'd put a 1 in those 2 spots. Does that make sense to you? All right, good. So this is the number of times per year. And if you're making monthly payments, then it's a 12. And if it's once a year, annual, that's 1. Just a 1. Okay. Now, the cool part is, from here, all you have to do is stick numbers into the formula and solve it. So let's just do one together. And I encourage you to leave this one alone because this is your notes, okay? And you're going to want, on the day of the test, which is coming in Thursday, word to the wise, this would be the one where one last cram session, 2 minutes before the test starts, looking at this and going, what's P again? Oh, yeah, it's principal. V stands for, oh, yeah, the value, the end value. Anyway, little cram session right before the test to make sure you remember what these letters mean. Okay, now, let's write it one more time, except this time you're going to erase the letters and put in the numbers that I tell you in my little story. Okay, so here's my little story. Would you agree that generally speaking, the price of most things goes up over time? All right, so let's take a cheeseburger. Today, if you go to Smashburger, which has a pretty darn good cheeseburger, it's not like a McDonald's cheeseburger, it's a good, normally kind of cheeseburger, okay? You pay $8 for the cheeseburger presently, at the current time, it's $8. My question is, if we go out, let me think, let's just make an easy one. You know how old you are. I know how old I am. And I'm gonna do the subtraction and say, if you were 42 years older, you'd be my age. So we're gonna go 42 years into the future. In 42 years, you'll be as old as me. So $8 cheeseburger. 1 plus, could you tell, did I never said monthly, did I? So then this must be an annual rate. Do I really have to write divided by 1? No, I won't even need that. Okay. And I can tell you what rate it's going to go up only if you can tell me how much inflation will go up. See, we had about 8% inflation for 2 years in a row a couple of years ago. Okay. Thankfully, it's toned down. But we had 8% inflation going. Right now, it's down to like maybe 3% inflation going. Average over the long haul is about 4% inflation, 0.04. So if we just get average inflation, our $8 cheeseburger over the course of 42 years, 1 times 42, will be how expensive? Good real world question. When you're my age, what are you going to be paying for a cheeseburger? If you have any influence in the world as you get older, I hope you try to fight for less inflation. Because as it is, cheeseburgers are going to be expensive. But we'll change this question to be like 8% inflation. If that had kept up, you'll see that the cheeseburger would be just outrageous. And this is one of those little things. Inflation hurts the little guy. It doesn't hurt the big guys. The big guys have plenty of money and they don't care that much if the cheeseburger goes up. Okay? So inflation hurts everyone. So we have to keep inflation down. All right. So, honestly, you can type this in faster than I can. I'm hoping you have a V. Would you please compare the value in the end to the kid next to you? See if you got the same thing. All right. Did you get 41.54? Raise your hand if you got 41.54. Cool. If you got that wrong, I would almost guarantee that you did the order wrong. You did the order of operations wrong. Okay. All right. So now I think I just want to make one tiny little change. If we kept up 8% inflation, would you now recalculate and see how expensive that cheeseburger would be when you're my age if we have 8% inflation? What is 1.08 to the power of 42. Take that number times 8. The $200 cheeseburger. And that's just a normal cheeseburger too. Like remember, that's like an $8 cheeseburger nowadays. So that's probably not going to happen because we're not going to be dumb enough to cause 8% inflation to keep going like that. At least I hope we're not. All right. So this little formula right here is the only really new thing for today. But I think there's one question that uses P e to the RT, this guy. And if I tell you E is this number, and rate is R is rate, T is time, they're not that hard to do. You just stick the numbers in, see what you get. All right? So let's actually start your homework then. And it says in the title of the homework which problems you should do. So I know it's 1 through 4, and then I can't remember the rest of them. Can somebody help me with that? It's problems 1 through 4, and then what? 6 and 8. Okay. So that's all you do is problems 1 through 4. Can you turn the key so it opens? 1 through 4, and then 6, and then 8. All right, here we go. Number 1. Josh, could you read that to me? Yeah. I'm ready when you're ready. I'm going to start by writing the formula while he's reading me the question. And it starts with that V.
The cost of a 20-ounce box of cereal increased from $4.25 to $5.50 over 5 years.
4.25 to 5 point what?
And 50 cents.
550 over 5 years?
Yes.
Awesome. Now I'm going to use that formula again. P times 1 plus R. And did they ever say anything about monthly? No, then it's R over 1, which you'll know is just R, to the NT, and you'll know that N is just 1. So then it's really just T. And then I'm going to put the P in for, remember, principal is what you started with. We started with $4.25. And the 5.5 is the value at the end. So we got 5.5 equals 4.25 times 1 plus the R to the 5 is the years. Now, from here, the only thing I could see a kid getting stuck on is how to start, and then you just divide both sides by what? Victoria, do you know? Divide both sides by 4.25. Then that cancels that. All right. And then, if you're still stuck, you're supposed to know that you put it to the power of 1/5 to get to the next step. All right. Usually people have trouble locking and unlocking that door, so I will go back there and fix that. And that's all I have for the video for today.